I'm Ondřej Mirtes, and I'm from Prague, Czech Republic, and I would like to thank you very much for coming to my talk. I must admit that this is really awesome opera hall, but I'm not going to be singing today. I'm going to be talking about how you should test your applications to save time and effort doing so. And I would like to start by comparing compiled languages and interpreted languages. So compiled languages need to know the type of each variable before the program runs. And they won't even let you run a program with some kind of obvious mistake like accessing undefined variable or calling an unknown method. So the compiler for a compiled language, like for example Java or C#, acts as the first line of defense before you can launch your application. But PHP is different. PHP is interpreted. So for example, when you make some mistake in some kind of nested condition, for example, if you are creating some e-commerce website and you have some kind of error in the third step of the checkout process, PHP will happily run the rest of your application, but when it comes to that line with the error, it will crash. So you will find out about it when your users or yourself get to that line of code. So PHP developers have to spend a lot of time uncovering such mistakes that are impossible to make in compiled languages. So I was really missing this compiler feature from PHP when I was working with Java at university, but I realized that something similar could also be created for PHP, because with the recent advancements in PHP language, like having scalar type hints or even type hinting at all, it's also possible to deduce these kinds of information from PHP source code. So I created PHP Stan. Who already uses PHP Stan in this room? Cool? Or at least heard about it? Maybe a few more hands up. Okay, so PHP Stan is a static analyzer. It analyzes your code without actually running it, as opposed to dynamic analyzer, which is, for example, some XH profiler or Xdebug. PHP Stan doesn't run your code. It only looks at its representation, and it doesn't actually run it. It just analyzes it and looks for some kind of dependencies and relationships in code, and of course for mistakes the developers do. So some errors are really easy to figure out, but some are more tricky. It helps you with writing PHP code because PHP itself is very forgiving about errors. So in neither of these cases, PHP actually doesn't complain when the class does not exist. So you can ask about instance of some class, and if the foo doesn't exist, it just skips the condition. It doesn't error. If you are catching some undefined exception, or if you are catching some type that isn't even an exception, PHP again stays silent. PHP will happily create a string with a class name, even if the part before the double colon doesn't exist. So it's really easy for errors to hide in your application without even noticed. But if you employ a static analyzer like PHP Stan or some other like Fen or Psalm, they can help you with uncovering these kind of errors and help your application work better. So how do they do it? So what's helping static analyzer is something called a type system. So what is a type system? Type system has a really long article on Wikipedia, but I won't bother you with it. Type system answers this question. Are parts of a program connected in a consistent way? If I rephrase this, does an application work from type's point of view? So, for example, if you promise to return a string from a function, but you return a null or an integer, you just broke the type system because you are not adhering to your promise. And if you look at this code, you probably realize that this can be checked statically. This can be checked with a machine. You don't need to waste your developer's time to check this manually during code review or by running the application. This can be checked with an automatic tool. Another example of a broken type system is when you ask for a string or for some kind of type in a method, and you pass an incompatible type to the method. So that's also one kind of error. If you are calling undefined methods on types, it's also a broken type system. But this is already more tricky because in PHP you have a feature called magic methods. So you have the __ call method, which you can implement on a class, and you can define any kind of method on an object. So this is already more tricky for a static analyzer to figure out, and compiled languages usually don't have these kinds of features because it will break the compiler. And actually, PHP stem can work with this kind of situation because you can actually write extensions for it that can help you describing how these magic methods are created in a different way for the purpose of static analysis. Unfortunately, properties cannot be, the types of properties cannot be defined natively because we have to wait for PHP 7.4. In PHP 7.4, we will be able to move the type before the, after the visibility keyword, before the name of the property, and we will be able to also document natively what kind of types properties have. But right now, you can write these types in PHP docs, and I really recommend it because PHP docs actually don't mean anything for the PHP runtime, but they can help a lot of static analyzer to find errors in your code. So some problems that static analyzers find are not actually like real bugs in your code. They can just find documentation issues which you also should fix. Another kind of examples are accessing private properties from outside the class, or accessing array offsets on objects when they are not supported, or accessing undefined constants. Another problem that static analyzer can find is an impossible comparison. So for example, if you compare different types using 3 equal signs, or you compare incompatible types, incompatible classes using instance of, static analyzer can tell you that this condition is dead and you should probably fix your condition, or that you can just remove it. So unless bar is an interface or bar is a parent class of foo, this condition will never run, and PHP stem will tell you about it. And there are many more kinds of errors that people usually make in their source code, like unused closure uses, unused constructor parameters, which can all be fixed if you employ a tool that tells you about it. Okay. So who writes tests? Cool. Lot of hands up. And who uses continuous integration? Cool. So PHP stem looks for bugs, but you also write tests to find bugs. So there's some kind of overlap. There's some kind of intersection of these two circles. Some bugs can be found by both tests and by PHP stem. So why should we test for things that can be found by static analysis? Because there's some duplicate effort, and we could probably save some really expensive developers' time doing that. And also, tests have to be written, they have to be maintained, and sometimes writing tests is boring, so probably no one likes writing tests for getters and setters. Or does someone? No, no one. But you definitely have setters and getters in your code. So you can realize that you don't have to write tests for every piece of code. And in this talk, I would like to tell you how to save time properly by only testing the pieces of code where it matters the most. Yeah, so static analysis is free, and we can actually move those circles so there is no overlap, and we save some time. And while we are at it, we can help PHP 7 understand our code better and better, so it can find even more bugs. So we can even write less tests and still have our application reliable as it should be. So, of course, I'm not saying that you don't need tests at all, but by saving some effort, you can actually focus on where they matter the most, which is business logic. And it might be a controversial thought, but I think that 100% coverage, who has 100% code coverage in their code? Almost no one. So I think it's expensive and wasteful, and it can be achieved only with some big sacrifices. So this is also why PHP 10 exists, to help you find some bugs. Okay, so this talk can be divided in two parts. First, I will tell you some local tips how to write your code that you can apply on a small scale, and then I will proceed to tell you some tips how to structure your application so you can write clever tests that help you find as most bugs as possible. Okay, so my first tip is that you should turn on logging notices. So who logs notices in their error logs? Okay, and the rest of you should actually turn this on, because notices are the worst bugs that can happen in your code. Because notices mean that we are accessing undefined variables, we are accessing undefined array keys, and the code becomes very unpredictable. So when you access an undefined variable, the execution of your code actually continues, and it uses some, I don't even know, like from my head, like what kind of value does it use? Does it use like empty string, or does it use null or something like that? I really don't know. And you shouldn't actually rely on this behavior, and you should fix your code so that it doesn't generate any notices. Because when we first done it, when we first started logging notices in our production at my day job, it found a lot of bugs that were lurking in our code previously. Another tip is that you should learn something about defensive programming. So you should actually let your application crash on a first unexpected state, unexpected behavior, and you shouldn't try to recover from this state and continue with execution, because then you will have an infinite combinations of states that your code can be in, and you should decrease this number of states to a minimum. So, for example, when you cannot connect to the database, you shouldn't try to show something to your user you shouldn't try to recover from not being able to connect to the database. You should just throw 500, error HTTP 500, and fix this error in production as soon as possible. And that applies to other errors as well. So you shouldn't try to recover from some weird state. Okay, so who uses PHP 5.6? Who uses 7.0? 7.1? 7.2? Okay, cool. that's very good. At 7.3? Okay, and is there anybody who didn't raise a hand, so they use PHP 4 or something? No, fortunately not. Okay, so for those who aren't, or the newest version, I recommend you upgrading, because you can really benefit from a newer PHP version. You can write nicer code, you can write safer code, and with PHP 7 you get a really nice big performance bump. So I will go a little bit through history of type hinting in PHP versions. In PHP 5.6 you weren't able to write scalar type hints, so you had to resort to PHP docs, which actually don't mean anything for the runtime, but still can be used by static analyzer. So, and of course IDs like PHP Storm. In PHP 7, PHP 7 allowed you to write scalar type hints and also return type hints, which is very important. But you still couldn't write nullable type hints. So the only way how to achieve native scalar nullable type hint was to actually make it optional. So in PHP 7.0, the only way how to make a nullable string was to make it was to write equals null, which also made the argument option, not just nullable, but also optional. So It means that if you want to be able to erase some kind of name from an object, from an entity, you would also allow the developer to call the method without any argument. So actually calling setName without any argument is ugly and does not make any sense, but it was the only way how to achieve this. So if you upgrade to 7.1, you actually are able to make these kind of calls make much more sense, because if you want to remove a name from an object on 7.1, you will have to call it with the null argument, which makes much more sense, setName null instead of setName and just parentheses. And also you can write nullable return type hints. Okay, PHP 7.0 also introduced declare strict types. Who uses strict types in their code? Okay, there should definitely be more of you, because a few minutes ago I talked about notices and how they help us find a lot of bugs in our code. Strict types were also able to find a lot of bugs in our code, because they found even we write tests, and they even found tests that don't make any sense. So turning strict types on will also help you to find a lot of bugs. So, and what they actually do, they in a file, when you type this out, they will make your method calls and function calls accept only types, only the same types. So if your function requires an integer, it will allow only to pass in an integer. If it requires a string, it will only allow to pass in a string. The only exception is that floats also accept integers, because it's a lossless conversion. And you should ideally use a coding standard that, for example, PHP code sniffer, that will enforce you to have this on top of every file, so that even if when you are creating a new file, the developer is not going to forget at this line at the beginning. And if you are starting with strict types, you definitely should not turn them on all at once in your whole big legacy application, because it's possible that you would break a lot of things. So I recommend to proceed only like one file at a time, or one folder at a time, well, one namespace at a time, to add those and observe what they actually do in production and what they do in your tests. Okay, so now the type in 7.1, I already talked about it. Next thing is stringly typed code. Who is familiar with strongly typed code? Cool. So if you use strict types, you have strongly typed code. And stringly typed code is actually play on words. And it's good to write scalar type hints like strings or integers where they belong. But you can do better, because when you use a primitive type like string or integer, you should really think about if you really want all possible strings in there. So for example, if I type out string name, I have to think if all possible strings, if I want to accept all possible strings. So is an empty string a valid name? Probably not. Is a string only concatenated from emojis also a valid name? Probably not. And stuff like this. So for example, if you are accepting hours in a day or minutes in an hour, you should use a special type, because an integer is not telling you actually what's the limitation, that you shouldn't probably use 61 for a minute or stuff like that. So trimming down possible inputs actually reduces undefined behavior. So you should use the most precise type for each input. So using objects actually brings you 3 separate benefits. So first, they should be consistent and validated. So if you are accepting an email somewhere, you should make sure that the actual value inside the email object is valid. So if you are creating the email object, you should validate in the constructor of the email object if the email is valid. And that allows you to actually not waste duplicate effort validating an email inside the method body, inside the method body. So you can only validate it in one place in the email constructor, and you don't have to using defensive programming, you don't have to validate it again inside each method body. That's first benefit, having consistent and validated values. Another benefit is that you are actually communicating with the type hints, you are communicating to the developer what can be passed inside the function. So if your original emails were strings, you wouldn't actually communicate to the developer what kind of values can be passed inside, because they could pass inside invalid strings, or they could make some mistake and pass only like a TLD there or something like that. And so it also is some kind of documentation. And third, the object will actually tell you what you can do with it. So when you look at public methods on the interface or on the class, it will actually tell you what you can do with the object. Again, like with the string types, you should, again, do it gradually. So if you have a lot of string type hints in your code, you should improve it one by one. So we also do it gradually, and really recently we started doing this for emails and for phone numbers, because for the longest time we used strings for that. But you can do it gradually to improve your legacy code base. Another tip, which you should what you should avoid, is overusing arrays. So with proper type hints, you actually can't call a method in a wrong way. But if you type hint only an array, you are not telling the user how the array should look like. So they can pass whatever they want inside a function. Again, you have to spend some time during runtime at the beginning of the method body if the passed array is actually valid. But we have a different way of doing that, and that's actually using objects. So if you pass some kind of array inside the function, some expected key might be missing. So the user might forget to add a name key. And we also, in this case, we also don't know the types of values. So the array could contain the key name, but it might be of a different type. It might be an integer or something. So I recommend you to avoid overusing arrays for this kind of scenarios and use proper objects. Another one exception is that array as just a list of values without any special keys is okay. So if we use array just to iterate over the same types of values, and we document those types of values again with a PHP doc, because we can't do that natively in PHP, then it's totally fine, and you don't have to avoid arrays in these cases. Another problem are ambitious functions that do many things at once. So it might seem really cool to write a function that says, I can process anything, throw anything at me, and I will do something about it. So there are problems with this, because methods that accepts multiple values have to contain some kind of branching logic to process these types separately. And if you have some extra branching logic, it means that you have to make sure to write tests for each branch. And another problem, again, is that you can't write a native type hint for that, so again, you have to resort to PHP docs. So I also wouldn't recommend it. Instead, you should write simple functions that do one thing, and they do the only thing well. So from the previous example, you can actually extract these values, you can separate these functions in two. One will accept array, and the other one will accept a string. And you can decide which function you will call based on the type of value that you have. So it's really possible that in one place of your code you have just strings, so you will call the bar function, and in the other place you have an array, so you will call the full function. And they can call each other internally, but the important thing is that the endpoint is different, and you will have less branching logic. And you should also apply the same principle to return type hints. So function that returns different multiple types based on the input should be separated into multiple functions. Another situation that you can stumble upon is when you have some kind of method and with proper type-ins like this one, and a new requirement comes that you should actually allow erasing these values. So you should allow nullables in there, so a user can actually delete these values, for example, in a form to save this entity without those dates. So the first solution that comes to mind is to add question marks, which is possible in PHP 7.1, and you make those parameters nullable, and this will allow user or developer to remove these values from the entity. But usually, when I see multiple nullable parameters at once in a method, it usually means that only some nullable combinations are valid, and some are not. So actually only the first two lines are intended usage of the method. The third and fourth line isn't. And this isn't obvious from the method signature, but the original intended usage was to set both dates or remove both dates. And it actually doesn't make sense to have only the from or only the to. So bulletproof code that actually doesn't let you do this would mean that you also have to have some branching logic inside and throwing some exceptions in case that the user doesn't pass arguments as you intended him to do. So when I encounter a situation like this, I try to recognize the different use cases of the method, and I try to name them, I try to label them, and I create different methods for these use cases. So the first one is the method as it originally looked, and it doesn't allow passing nullable values in there. And then I have a second method that actually does the use case, the second use case, as I wanted it to do. So we have setting the dates and we have removing the dates as separate methods. And this is really good idea to do it like this, because you are gaining the benefit that this can be verified statically if we are calling the methods correctly. And you don't have to have any additional write time check inside the method, and you can save some time during testing. Okay, so again, also I would like to discourage you from writing dynamic code like this, because static analysis cannot recognize what this code does, and neither can your developers recognize what this code does. And also, if you are calling dynamic methods or creating dynamic classes like this, you are also risking that you won't pass some required arguments into the method or into the constructor. So I would also like to discourage you from doing that. And PHP allows you to use common strings as callables. So it's kind of writing PHP code inside magic strings. But this also has problems, because these calls are usually not found when you ask your IDE for usages of your functional methods, and there are also some other problems with this. So this is an example from JavaScript. You might have seen it somewhere. And from the first line, you probably wouldn't guess that the result looks like this. It's not 1, 2, 3, but it's 1 and not number and not number. And this is a problem, because the map method has actually some side effect. So parseInt function actually accepts 2 arguments. And the map method on an array is passing to the callback the second argument, like the array key of the value. So it's accepting a numeric base of the number. So the first value is parsed as expected, and the second one isn't, because 1 isn't valid numeric base, and 3 isn't valid number in base 2. So it doesn't work. And instead, I would like you to get rid of all magic, and I would like to actually write PHP code. So even if we can write a clever shortcut using the function name in a string, I would like you to start using anonymous functions even for the simplest of calls. Because in this case, you won't have any side effect, and you are actually writing PHP code all the time. So your IDE can find this during renaming and during finding usages and things like that. So explicit arguments passing actually, again, reduces unexpected behavior. Okay. So who uses loose comparisons using two equal signs in their code? Okay, or exclamation mark equals. So loose comparisons also lead to a lot of unexpected mistakes. I circled the weirdest ones. So for example, string with a 0 in it equals to false. And empty array equals to null. So this is really weird. I would like you to use 3 equal signs, and this behaves really in an unexpected way. The type and the value must be the same, so the green circles are actually where you would expect them to be. Another thing that I would like you to avoid is using empty, which has a lot of the same shortcomings. It's also too loose of a comparison to be practical. So all of these things are actually empty. So it's not very fit to be used, for example, in validation, because if you are validating strings with an empty keyword, and someone enters a 0 into your input field, you probably don't want it to be empty. You probably want it to pass and to be saved to your database. And you should use more specific comparisons, like a count on an array, to check if it's actually what you want it to be. I have one refactoring tip for you. If you're changing a return type of a function or a method, you should rename it, because renaming it will force you to go through your whole application and fix those places by hand, fix those places manually. So if you, for example, change a return type of a method from a single value to an array, renaming it will force you to actually go through all those usages and change the usage of a single value to, for example, a for each. Okay, so those were local tips about your code that you can apply on a small scale. And now we'll go through structural tips that are about the whole application. So who wrote an application in their lifetime that looked like this? Okay. And who writes code like this today? Cool. So as we learned, as we matured how to write PHP code, we moved everything to classes and methods. And it has the benefit that we know where all the variables, where all the types come from. And no code should be actually in the global scope. Okay, so this is how ideally your types should flow through your application. So the first step is inevitable. It will be always weakly typed because that's the nature of HTTP. And everything in an HTTP request is a string. So the URL is a string, the postboard is a string. And the role of the controller in your MEC framework or in your homegrown solution is actually to validate everything and to make strongly typed values from those incoming data before sending them further down to the road to your business logic, to your model, and so on. So if you let strong types spread through your application, they will make it much more reliable, because everything is checked and everything is type solid and everything is verifiable by a static analyzer. So not all code is created equal with regards to importance and probability of a bug. So I differentiate the code of an application into two types. First, there is wiring, and second, there is business logic. So wiring is actually what holds the application together. So it's the glue between layers. So this is the list of what usually wiring represents. So it's controllers, facades, passing values somewhere else, getters, setters, assigning group properties, and so on. And I suspect that more like 50% of code in modern application is wiring. And the more complex architecture you got, the more wiring you have. And wiring is actually not useless because it enables reusability, clarity of the code, testability, and maintenance. And it allows us to extract common pieces of code and call them from multiple places. So I'm not saying that you should avoid wiring. And business logic is actually what we are paid to do for our application to do. So what is actually the main goal of the application, what business is interested in. So static and as you imagine, wiring is where you can actually save on testing, but business logic is where you put your testing efforts. So static analyzer will tell you that you are calling an undefined method, so that's the wiring part, but it won't tell you that you are rounding your numbers in a work way that you should have used floor instead of ceil and so on. And yeah, so business logic is usually value validation, arithmetic operations, filtering, parsers, state machines, if conditions, and loops. There's one catch that you probably ask yourself, is that some bugs can find their way into wiring and they can't be detected by static analysis. And that happens if some values are interchangeable because they use the same type, and stuff like this can happen. So we can actually interchange the properties assigned in the setter. But this becomes more rare and rare as you use more custom types for everything, because there's less probability of making them interchangeable. So I think that this is not the reason to write tests for wiring. So unit tests are my favorite kind of tests because they provide fast and accurate localization of a bug if they fail. So if you write tests, the majority of them, in my opinion, should be unit tests. And unit tests are awesome because they won't fail randomly, and they are not dependent on your network working, and on your database being up, and they should not access your file system, and they also shouldn't need the rest of the application to work. But what is the common mistake that people do is that they interweave their data fetching with business logic. And in this case, they have to use mock objects. But mock objects are really tricky because they represent white box testing, which means that you have to see how the code works inside before you can write a unit test, so you know how you should configure your mock object. So it's white box testing, and they can break down. They can fail really easily with the first internal change to the tested code, because then you will have to reconfigure your mock objects, and if you use a lot of them, then no one can actually understand what's going on inside. So I don't recommend putting data fetching and business logic into a single class, into a single method. And even if you actually extract your SQL queries into a repository, you can still make the same mistake and call the repository inside the business logic, which is not recommended. So instead, you should remove the need for mocking. You should actually extract your business logic. You should actually realize what are the inputs and the outputs of the business logic, and you should actually make the inputs and inputs to method. So your business logic should actually be completely separated from your persistence layer, and it should happen all in the memory so that you can simply write your unit tests without a need for mocking. because also your value objects, your inputs to your business logic should be easy to create. If you need to mock your value objects, then it's a kind of a feedback that you should probably simplify them and make them smaller. So this is how the values flow if you adhere to these tips, is that you have your business logic with clearly defined inputs and outputs, and this business logic is called from multiple places in a different way. So in production, some other class, some other layer, probably called facade, fetches the data from the repository and passes them to the business logic. And in our testing efforts, in our unit tests, we actually don't have to access the database, we don't have to mock anything. We just create the same data manually that are created by the facade, and we can unit test our business logic to a great extent. So in practice, it looks like this. The facade fetch the data and pass them to a business object and does something with it. And this is actually wiring. This is just passing data along to allow us to structure our code that way that it's easily tested. And the only thing that will be tested is actually the calculator, the business logic. And who knows this feature of PHP on data providers? Yeah. It's a really, really awesome feature. So when you structure your code this way, I really recommend using data providers. Because when you structure code this way, you can write new combinations, new test combinations really easily. So you can really test your business logic thoroughly to be sure that there are no bugs lurking. Okay, I'm almost at the end. So this is kind of a funny situation. And it's funny, but I don't actually find this true. Because if I unit test two classes in a compiled language or in PHP with the help of static analyzer, if I type in my return types properly, this actually cannot happen. Because the static analyzer can verify that the results of one class can be passed into another class. So this is even more a rare situation. And if you are not using mocks, then this is even more rare. It basically cannot happen. But integration tests have their place, for example, for testing communication with external third-party systems, because you have no other way of verifying that you integrate with them well. And also, this approach that I just showed you probably requires using an object relational mapper like Doctrine or some other solution. So who uses an ORM? And I recommend it, but some people use it for the wrong reasons. So for example, if you really hate writing SQL queries, it's not the right reason to use an ORM, because ORM must have to guess what you are actually trying to do and will generate inoptimal queries for you. Another wrong reason is for using ORM is that you probably will want to switch to another database later, but no one ever successfully did that, because even if there is a common standard SQL, different databases actually are behaving in a different way. So if you are only limiting yourself to a common subset of all the databases, then you are not actually using your choose technology well. So when you are using, for example, Postgres or MySQL, you should really use all the features that this database is allowing you to do. So this is also a wrong reason to use an ORM, to be able to switch between multiple database types. But why I use ORM is that it allows me to represent data rows, like data from the database, using objects in my application. So I can properly type in them, I can write proper logic in them, I can unit test them, and they allow me to use strong types throughout my whole application. Okay, so if you like this approach and you would like to know more about it, I wrote an article about this kind of testing strategy in April 2018 issue of PHP Architect Magazine. And this article, you don't have to buy this magazine, you don't have to subscribe to it, because this article is one of the free available ones on their website, so you can take a look. Okay, so that's all from me today. Thank you very much. Okay, now it's probably...
Ondřej, we have like more than 10 questions for you, so I don't know whether you can keep it. You have like 10 minutes, so fire it well.
Okay, so do you use PHP Storm for static code analysis inspection? Yes, I do. There's an awesome PHP inspections plugin for PHP Storm, but it's not actually like a competition for PHP Storm or other static analyzers, because PHP Storm in usual day-to-day job is actually much more forgiving. So for example, if you type into your property in some way, and then you pass a different kind of type in your constructor, then PHP Storm will actually trust the type from the constructor, and it will ignore your @var annotation above the property. So, and you also can't run IDE easily in your continuous integration. So actually, you should use both, but all of them have some place in your work and in your pipeline. What is your opinion on some popular frameworks refusing to adopt stricter typing system? What benefits does that bring? Yeah, so Laravel code is actually pretty analyzable these days because PHP Storm is extensible. So you can write some kind of extensions that will allow describing the magic methods, magic properties in these kinds of frameworks. So you, traditionally, this wasn't a very static analyzer-friendly code, but right now it is. So it's now possible to analyze even more magic code like this. So I'm not really worried that some people don't want to adopt more strict types, because there are ways around it, and users of these frameworks can still benefit from this. New dollar class is a great mechanism for factory and polymorphism. This is the alternative you would recommend. Well, you can probably use something like reflection there, but I would only use reflection like in some infrastructure code, like in a system code. I wouldn't want to use reflection and these dynamic approaches in business logic, because business logic should be as strict as possible, and this magic behavior should only be limited to infrastructure and not to business logic. Can you briefly compare PHP Storm, Psalm, or Fun? So I might be a little bit biased because I created PHP Storm, but they are all great tools. I'm not actually familiar much with Fan, because it requires the PHP AST extension to be loaded in order to run it, and PHP Storm and Psalm do not. But I would say that Psalm is really great if you are an advanced users and you, for example, know what are and you want to use generics, which are pretty common in other languages but not yet in PHP. So if you are already pretty familiar with these kinds of advanced features that are not yet in PHP, you should use Psalm. And PHP Storm is great if you are starting in this area and you want to get from loosely typed code to a strongly typed code. And also PHP Storm, to my opinion, has bigger ecosystem of some other extensions for frameworks. So for example, when you are using PHP Storm with Doctrine, it can statically analyze that your DQL queries are actually correct, because it can scan them statically in your code. It knows about your entities, and you can do this to eliminate classes of bugs. And there are also extensions for Laravel and PHP Unit and frameworks like that. Can PHP be part of CI? Of course, because it can be run from CI, and it returns exit code greater than 0 if it fails. And how it can impact on build time when application has dozens of thousands PHP files. So I like to use GitLab CI, which actually allows you to parallelize your build into multiple jobs, into multiple workers. You can scale those workers, for example, on AWS. So you shouldn't stop using some tool because it slows down your build. Because if the tool brings some benefit to you, you should always run it. And you should find some way how to make it more fast, for example, with some kind of caching or analyzing only change files or stuff like that. PHP doesn't have method overloading. Actually, it does. So there are some. I know it because I have to accommodate for that in PHP stand. So there are some functions that are actually overloaded, like strtok or pdo query method. Okay, but we can provide it by setting multiple different types and branching of what's your opinion method overloading. Well, it's only possible in PHP internals. It's not possible in userland code. So you should probably avoid that, and you should name your use cases in a different way. So it's similar as I showed you to the nullable arguments example. You should define those use cases, and you should name them differently, and you should use different methods for them, because that way it will work in a better way. And yeah, what is your opinion on Laravel, since it relies on dynamic code to a great extent? I already talked about it. It's magic. It's still possible to describe, but myself personally, I like frameworks that are actually like strongly and statically typed from the beginning, so I can, for example, use my AD to click through the implementation. But it's possible to statically analyze Laravel and magic frameworks like that. Edge cases where you would accept dynamic code acceptable. As I said, it's possible to use it in infrastructure code. So for example, when I'm using Doctrine, it uses reflection and magic behavior internally, but it's actually not exposed to the user, to the developer in the business logic. So that's where it's acceptable. In wiring example, would you unit test the wiring facade using mocking to see the services are being called, are their values passed? I think it's not necessary to unit test the wiring facade because you would have to use mocks there. And actually, you can use some other methods to see if everything that's injected into the class is used. So you can use some detections in PHP stand or, for example, in PHP code sniffer that actually checks that all the parameters that are asked for in the class, in the method, or all the properties that are injected into the class are actually used. So you can know that everything is used without actually writing unit tests. How to properly document callable parameter signature? Yeah, there's a way, but I'm not probably able to switch to my computer again. So PHP stand actually supports some syntax that you can write. It's okay. So you can actually write PHP doc, for example, at param, callable or closure with capital C, and you can actually write the parameters like this. And it will understand what's going on, and you still need the parameter name. So PHP still understands this, but of course, with these kinds of approaches, it's hard to use them in practice because they first need to get support in other tools like PHP code sniffer, various packages, and also in the IDE. So it's hard to use them always, but if you are not relying on a specific IDE, you can start using it, and PHP stand will understand this. Another example like this, oh, please back to the monitor one more time. One more example like this is that if you want to describe, for example, collection of items. So let's say that this is an article. So normally this would mean that you are having a collection, an object, or an array of articles. But historically, this usually means that you are having collection of article objects. So PHP stand needs to use some heuristics in order to work with this. But recently, like a few months ago, PHP stand and PHP Storm, the IDE at the same time, started supporting this kind of syntax. So you can actually use this one, and it's less ambiguous actually about what does it do. Okay, back to the questions, please. Can you tell more about levels in PHP stand? Okay, so PHP stem is already pretty capable, so when you currently run it, without any kinds of levels, it would output hundreds of errors or thousands of errors for your application, which would discourage you, and you would uninstall it, and you would never use it again. So I implemented levels, and those levels are actually replicating the initial experience when I implemented PHP stem, the first version, and I implemented a single check, and I use it in our company's code base. So I implemented the check, I fixed all the bugs that it found, and I merged those fixes to master. But right now, PHP is already pretty capable, so I implemented something called levels. You should start on level 0, fix all the bugs, then come to level 1, fix all the bugs, and merge it to master. And when you have time again, for example, in 2 weeks, you can increase the level, fix all those bugs, and so on. So these are levels. And about what levels do, what each level actually checks, well, there's a list. You can actually check the implementation, check the configuration files, but basically it doesn't matter because you should actually check what PHP stem finds in your code base, and it's not an experience that is easily replicable across multiple companies, multiple code bases. Did you try PHP metrics? No, never heard about it. I know about PHP Insights, like new package from Nomadro, and I also know about PHP MD, but PHP metrics I never heard about it. GrumPHP is, I think, a tool or a package that actually composes of multiple static analysis tools, and you can run them all at once. But actually, in order to use them to full extent, you need to configure each tool separately. So if you run it GrumPHP all at once, then it can probably find some problems. But if you really want to take advantage in full, you should install, you should learn, and you should configure each of these tools separately in order to take the most advantage of them. Okay, so thank you very much.